Welcome to The Explainer. Today, we are taking a deep dive into one of the most exciting stories in AI right now, the incredible rise of the DeepSeek models. So, how in the world did an open-weight model get so good that it's now challenging the biggest names in the game? Well, let's get into it.
Okay, let's not waste any time. Just look at this chart. Right there, you've got DeepSeek V3.2, an open-weight model, going toe-to-toe with the closed-source proprietary giants like GPT-5 and Gemini 3.0 Pro. I mean, it's not just playing in the same sandbox. On these crucial benchmarks, it's a legitimate top performer. This is the kind of result that makes everybody in AI, sit up and pay attention.
And that, of course, leads us to the big question, the one we're going to answer today. How did they do it? How does a model that anyone can access and build upon reach this kind of performance? Well, the answer isn't some single magic bullet. It's a fantastic story of smart, step-by-step innovation. And we're going to unpack that whole journey.
To really get it, we've got to start at the beginning. Our story kicks off with the foundation, the original DeepSeek V3, and the core ideas that really set this whole incredible chain of events in motion.
And this timeline, it tells the story perfectly. You can just see this methodical, deliberate progress. It starts with V3 near the end of 2024, and then you see these specialized models pop up for reasoning, for math, all building towards the absolute powerhouse, V3.2, just 1 year later. This wasn't a single lucky leap. It was a series of really smart, calculated steps.
So the first critical piece of this puzzle was a technique called multi-head latent attention, or MLA. At its heart, this is all about one thing: efficiency. See, for an AI to have a conversation, it has to remember what's been said. But storing all that info is a huge memory hog. MLA was their clever strategy to shrink that memory footprint way down.
The easiest way to wrap your head around this is to think of it just like zipping a file on your computer. MLA takes all that important data the model needs to remember, its short-term memory, and it just compresses it into a much smaller, more manageable package. This lets it handle way longer conversations and process information much faster, all without needing a warehouse full of GPUs.
Okay, so with memory efficiency getting sorted out, the next goal was to make the model smarter, a better reasoner. That's where a new training method came into play. The idea was to teach the model to find answers that were provably correct, especially for things like math or code. The trick was to reward the AI only when it got the reasoning right, which really sharpened its logical abilities.
But here's the thing. As models get better at reasoning, they need to read more and more information at once, what we call long contexts. And that created a whole new bottleneck, which of course led to the next massive innovation, a giant leap forward in efficiency.
And this explains the problem and the solution perfectly. Standard attention, the old way, is like having to read a 1,000-page legal document word for word, just to find one name. It's thorough, sure, but it's painfully slow and super expensive. Sparse attention, though, that's like an expert who can just skim the pages and their eyes intelligently snap to only the most relevant sentences. Fast and incredibly efficient.
Now, DeepSeek's secret sauce for this is called DeepSeek Sparse Attention, or DSA. You can think of it as this dynamic duo. It has a lightning indexer that instantly figures out which parts of the past conversation are important, and a token selector that grabs only those key parts for the model to actually focus on.
So here's how that team works in practice. First, whenever the model is about to say something new, the lightning indexer zips through the entire conversation history and slaps a relevance score on every single word or token from the past. Then, the token selector swoops in, picks only the absolute highest scoring tokens, the VIPs, and tells the model, hey, just focus on these, you can ignore everything else. It's basically a super smart filter for the AI's attention. So, what does all this technical wizardry actually get you? Well, the change in computational cost is insane. It's a total game changer. Before, the cost to process a long text would just explode exponentially. But now, it grows at a much slower, more predictable rate. This is the difference between a model just grinding to a halt when you feed it a huge document versus one that can breeze through entire books or code bases. Okay, so the model is now incredibly efficient. It's fast, but is it accurate? The next big revolution wasn't about speed, it was about logical rigor. It was about teaching an AI how to think more clearly and, this is the really cool part, how to catch and fix its own mistakes. And the DeepSeek team themselves put the problem perfectly with this quote.
right? It's just not good enough for an AI to magically spit out the right answer, because if it got there by just getting lucky or by using totally flawed logic, you can't trust it. It needs to show its work, and that work has to be sound.
Their solution to this is a process called self-verification, and the idea is brilliant. You essentially train a second AI to act as a judge. And this judge doesn't just look at the final answer. Its whole job is to carefully examine every single step of the main model's reasoning, hunting for any logical errors.
So let's trace this little feedback loop. It all starts with the main model generating an answer and explaining how it got there. Then, the verifier AI steps in, like a really tough professor, and meticulously checks the logic for any and all mistakes or gaps.
But it doesn't just say wrong. The verifier then provides really specific constructive feedback, pointing out exactly where the reasoning went off the rails. And finally, the main model takes that feedback, learns from it, and tries again, generating a new, refined, and much better answer. It's this cycle that teaches the model not just what the right answer is, but how to reason correctly to get there every time. Which brings us to the grand finale. We've seen the efficiency hacks that made it fast and the reasoning breakthroughs that made it smart. Now let's see how DeepSeek V3.2 combines all of these pieces to become a true heavyweight contender.
DeepSeek V3 really is the synthesis of this whole journey. It takes the memory-saving compression of MLA, adds the incredible long document efficiency of DSA, and then layers on top that advanced self-correcting reasoning from RLVR and self-verification. It's an architecture designed from the ground up to be both incredibly fast and incredibly smart.
And that brings us right back to where we started. But now, when you look at this chart, it's different, isn't it? You know the story behind these numbers. This wild performance isn't magic. It's the direct, tangible result of combining memory efficiency, smart attention, and self-correcting logic into one seriously powerful package.
So, beyond the impressive stats and the cool tech, what's the big picture here? Why does the story of a model like DeepSeek V3.2 actually matter for the future of AI?
Here's the key takeaway. The DeepSeek story is a masterclass in the power of iterative innovation. It proves that you don't always need to have the single biggest budget or the most compute on the planet to lead the pack. By cleverly combining these resource-saving hacks with truly sophisticated reasoning, the open-source community is showing it can not only keep up, but actually push the entire field forward.
And that leaves us with one last fascinating question to think about. We are watching open-source models become masters of two incredibly powerful things at once: computational efficiency and logical self-correction. As those two forces continue to combine and get better, it really makes you wonder, what does the future of leadership in AI actually look like?